as like a software developer and in the Institute of Technology North back in Brazil too, and also at the Federal University of the Amazon. I was like a researcher over there, and in the Fundação Paulo Feitosa, I work as a senior developer as well. So here is part of the background. And actually, right now, what I'm doing is in cloud computing is researching for this genomic data. So I wanted to search something that was related with healthcare. And one of the connections that I got was on on genomic sequence analysis. So in this genomic sequence analysis, it's central for us to investigate the information that have there and looking for the genomic sequence of a DNA. Can I classify, can I use the computer technology to understand features of a human being? So I can predict, looking to their DNA, what are the color of their eyes, what are the color of their hair, if they are going to have a sickness or not, if they have certain probability to have, you know, asthma or something like that, looking to their genome. Actually, in classical computer techniques can help us out on that, but they might be struggling whenever they handle very complex data or genomic data or some data that is very heavy on them, and which in quantum computing we would have way more space and way more alternatives to do a software engineering of this data, encode it in a smart way where we will be able to do those type of classifications and make it way easier to, you know, look for even more alternatives on applying the information in a certain way, like in healthcare, for example, right? So, and here we have like a diagram that I really like to talk, that is whenever we have a classical information in a classical computer, we can input, that's perfect. But whenever we have like classical computer in quantum devices, it's perfect too, it's good too. So we can input classical information in quantum devices. But when we have quantum information in classical devices, that is not going to match because it would be too much for a quantum device to work on. And quantum information in quantum devices, we're able to work on that. So, and then now what we are studying is actually all of this mindset of, okay, what my quantum device is able to offer to me. What do we have as a classical information? Can we transform it to input in our quantum device and then have all of the advantages on having our information in a quantum device? So how can we do that? So this is mainly what is my research about. And whenever we are inputting this classical information, and just let's stop a little bit and understand like what is a classical information. A classical information is something like it's 0 and 1. It's like a photograph that we take that at the end of the day is a whole bunch of numbers, and those numbers we can convert them to zeros and ones and then have the classical information in a very low level for our computer. But in the quantum information, we need to transform those zeros and ones in from bits to qubits. So this important part of transforming qubits, bits to qubits, we call encoding of the data, right? So we need to do like the contributions of my research would be to do optimal genomic sequence encoding, quantum machine learning classification, and also revolutionizing the quantum computing in genomics. So And here is a diagram. So we will have this data encoding, and also with unitary transformations, we will be able to do an output that is feasible and understandable according to our problem, a classification problem, for example. And here is like the conclusion would be that one of the broader impacts that we would have with this proposed work would be the advances in genomics and medicine, the ethical, like we also will have ethical and social impacts too. Because, oh, what if I have the genomic of a person and I already predict what type of sickness they have or they are likely to have, but they never had it. So if the employer see that, is he going to hire this person that have the prediction to have certain kind of sickness rather than the other? You know, we have all of a ethical environment that we will need to explore for it. And also the project innovative approach promised to push the boundaries of what is currently achievable in both quantum computing and genomic research, with the far-reaching implications for the future of the precision medicine and specific discovery. And here on the side, we can also see like, okay, but whenever we talk about this genomics, we're pretty much talking about the bases, that is A, C, T, G, and those bases that are going to give us a string can give us information about a certain person and predict certain kinds of sickness or an anomaly that we are willing to predict on it. And we want to use the quantum computation to be able to do that and explore in the quantum information theory from there. Yeah, so, and based on all of this, and changing a little bit of topics, actually, we want to say what would be my post-graduation perspective. I would like to teach as a professor, to be a professor in software and computer engineering, but I'm open to go to the data analysis research and also be a developer in the business area. Focus on the healthcare businesses or, departments from their researchers that are in healthcare. And, we don't know what the future comes, and maybe like a postdoc might be awesome too. So I'm just taking like one step at a time, but I think that this is one of my future perspectives. And here is like kind of a closing. I really like this phrase. So nothing is random in nature. A thing appears random only though the incompleteness of our knowledge. So if we think that something is random, maybe we don't have enough information about that. So in a classical world, we need to select the information that we are going to work with, do the inputs, and have an output. But in a quantum world, we can have many, like infinite inputs in order to predict something. And if we are not able to predict in the correct way, maybe it's because we're lacking on certain information that we are not able to observe, or we are not observing it. So, and at the end of the day, nothing is random. Yeah. And we can go and study and search for it and make our questions a future research. So, yeah.
Alrighty, thank you so much, Sthefanie. So now, great job, by the way. That was awesome. So now we're going to open the floor for any questions. I saw that we have a couple of them in the chat, so I'm going to go ahead and give probably the next 10 to 15 minutes to answer any questions, and then we'll go ahead and close up the session afterwards. Oh.
Yes, thank you so much. I can go ahead. I will read those questions Dr. Carbono, and he said like, do we need for different way to write a program when we are using quantum computer? Yes, yeah. I mean, mainly whenever I'm using quantum computer or doing quantum machine learning, I can't do it on my computer. I would need to connect with the cloud, and I would need to, research, like have a notebook on the cloud in the IBM. And from there, I will need to request like authorization, and they will give me cloud like access to their quantum computers. And then I will send my code to them. Pretty much what I'm coding would be in Python and with a lot of information and functions that are already developed in the library that is called Qiskit. So Qiskit is like a to-go, um, the to-go environment or library that if you want to come to this quantum world, this is the Qiskit is going to give you a lot of good um, tools to research on that and to do all of the coding. So it would be on Python and it would be on the library called Qiskit. So you need to put like the X gate, the OR gate, or Hadamard gate, and input the qubits that you want and do all of that, like all the quantum theory, you will transform it in a coding on Qiskit, and it's going to run on the cloud and send you the answer afterwards. So, yeah. And the other one is, what is the limitations of a quantum computer? So I would say that sometimes it is like we need to observe the data that we have as software developers. And I don't think that this would be a limitation that I'm saying, but it's like that. Let's say that you want to predict something that is very trivial for a quantum computer. For example, I have an image of cats and dogs, and I do a machine learning, and that would give me the classification of it. So sometimes, is that necessary for us to import all of this information in a quantum computer and then have those classifications? Maybe not, because you are trying to get like a huge environment to resolve a super small problem that just with like a small environment, you would also be able to resolve it. So sometimes we think like, oh, quantum computer is for everything. No, it's not. It's important for us to make sure that our data is almost like too much for a classical computer, so we go to a quantum computer. And another thing of a limitation for a quantum computer is the environment that we have the quantum computer. Because if we have the quantum computer in an environment that has noise, that will affect the information that is on there. So this is going to make all of the predictions and everything be done wrong and give us a result that we don't expect. So we need to have a very uh, huge like controlling on the environment that we are, and um, we can't have like a quantum computer in today's days in our house unless if you want to spend like a lot of money on energy to have like a zero Fahrenheit and have like a pseudo closed box for the quantum computer. So we need a laboratory, we need like researchers around to be looking for it all the time. So definitely that would be a limitation of the quantum computer. Yeah, like once we have noise and interference with the from the environment, our prediction will not be as accurate. Yeah. Um, Thank you, Aurora. Great job. And let me see. Absolutely. Let me see. Oh, Luis, it's saying, is it the same quantity as having a quantum computer? I guess like in the quantum computer, it is the same quality as having a quantum computer. I guess in the classical computer, it's going to give us certain support, and in the quantum computer, we'll need it just for more complex problems. So it's valid, the classical computer right now, you know, in the classical computer, we can have like a small device like our phone, and we can access in a very easy way without controlling, without, you know, all of these environment things that I was talking about beforehand. But in the classical computer, we have very good, easy access. In a quantum computer, it's not that easy right now, and we need to control it all the time. So but the quality of having a lot of information in the quantum computer and doing the prediction, it's supposed to be faster. So when we are trying to do this prediction, it might be faster, it might be more accurate depending on how you are encoding the data and depending on how you have like everything set up. And what we predict as researchers is to have the same, as researchers, we predict that we would have the same accuracy as a quantum computer, as a classical computer, or better. So the quantum computer will be as good as the classical computer or better. We are going to this curve and trying to achieve this pattern mark right now. And once we achieve that, it's just going up like exponentially. So this is what we have like as a probability. Yeah. Dr. Carbono, very good. Congratulations. Thank you so much. Yeah, I think that any other questions that you guys have?
Yeah, I have one more super quick one. So I know that your educational journey didn't begin at UTSA, so I just want to know what your UTSA ECE, your department specifically.
Yeah, so in UTSA, let me just also, I can go ahead and try to show this. Yeah, so the electrical and computer engineering department at UTSA, they have one major in electrical engineer, they have another major in computer engineer, and a double major in both. And at the same way, they had like the PhD in electrical and computer engineer as
So
soon as
with
I
all
entered.
these Hilton honors points,
But whenever I entered, like in this in the bachelor's, I mean in the PhD in UTSA, they are willing to start the computer engineer PhD program. So now it's going to have like two different types of PhD, the electrical engineer PhD and the computer engineer PhD. So it's pretty much like that. And the difference between one and the other is that one will be more focused on computer devices and all of this programming logic and hardware of the computer. And in the electrical engineer, it's a lot of optimal control, mathematical understanding, physics, and things like that. And particularly speaking, as in my formation, you know, I did my bachelor's in software engineer. So I'm more familiar with computer engineer rather than electrical. Yeah, so that definitely was a challenge for me because switching from software, I mean, coming from a background of software engineer and coming to a department of electrical engineer, I would need to overload my studies with more math than I expected. And this, you know, definitely gave me a lot of knowledge, and it was challenging, but definitely gave me a lot of knowledge on the other hand too. So, yes.
Thank you so much. And I just have one last little follow-up to that. So what connected you specifically to the Clear Lab?
Yeah, so during my research in UTSA, I was in a concentration of control theory. And
Mhm.
whenever I saw the class from Dr. Previous of quantum computer and machine learning, or quantum machine learning, I was just like, whoa, I am a specialist in machine learning and deep learning, and I haven't heard about quantum machine learning at
Mhm.
all for all of these years that I have been studying and researching. I want to, I think that this is a differential and can make me a differential professional.
Mhm.
So I went through this class and I got to know Dr. Previous. And then I saw that that motivated me a lot and gave me, it was challenging, but it gave me a lot of motivation. So I was just like, yes, I think that this is a good path for my research. I think that I'll continue being motivated because it's something that it's brand new for me and is very, um, what's the name? It will come like with development.
Mhm.
It will come with math and algebraic, basis. So it would connect a lot of worlds that I know that it would give me a good research. So that class gave me like the motivation, and you know, in the class I met Dr. Privas, and now we are researching together. Yeah,
Alrighty. Thank you so much for sharing that, Stephanie. That's really great. You're doing excellent work. So,
thank you.
are there any other questions?
Yeah, and I just wanted to say like thank you so much for everybody that showed up here
Mhm.
and send a message on the chat and gave me questions. I appreciate that, and yeah, thank you for listening.
Alrighty. So if nothing else, I think we're going to go ahead and wrap up the session here. I want to thank everybody for attending. I'm going to go ahead and stop recording the session now.